Hi, it's Mr. Mac, and today we're going to be looking at concrete. Yes, concrete. Concrete is an amazing building material, and it uses both physics and chemistry, and a bit of mathematics to try and work things through. Yes, today's video is all about concrete.
This is Mr. Mac. He can explain things really well and is a lot of fun to watch. You can subscribe to Mr. Mac's Physics channel. You will find mathematics problems, science demonstrations, astronomy and space pics, physics calculations and simple explanations of advanced concepts.
Concrete. Yes, concrete. I was watching this path being poured, and I just got really enthused about concrete. Concrete, we can make all sorts of wonderful things. We can build buildings. There's a roundabout you can see is made out of concrete. There's curbing. There's patterned concrete. And even in the background here, you can see prefabricated concrete drain, a footpath, patterned concrete, all sorts of things that we can make with concrete. And I find that there's some architectural beauty that is made with concrete. This is the Sydney Opera House, and it is amazing. It's actually two buildings, one inside the other. In fact, four buildings, if not five, when you start counting. It's just amazing structurally, and it's an amazing engineering design, and it's using concrete. And some of this concrete requires strength up to 100 megapascals of pressure. And here is Mooney Mooney Creek Bridge, bridges for freeways, which require concrete and this incredibly high structure that takes incredibly high loads. And this is the concrete truck and the concrete pump as they are coming in. And so the first step, of course, is to build the formwork. It's really critical to get the formwork right. Plywood can be used, or treated pine, or metal beams that are made to measure. Here there are hardwood pegs spaced about 500 millimeters apart. The formwork is secured to the pegs using 50 millimeters bullet head nails. The pegs are then braced with a kicker if the formwork extends more than 150 mils above the ground. And you can see one of those here. The path in this case is 50 metres long. Believe me, I walked and measured it. It's 1 metre wide. I found that out from the on-site property manager, and it has an average depth of around 100 millimetres. So using some maths, V equals LBH, that's the volume of a rectangular prism, is length times breadth times height. 50 times 1 times 0.1, that's 100 millimetres in metres, is 5 metres cubed. So the truck must bring at least 5 cubic metres of concrete in its rotating tumbler. Now, usually they do 10% above that. In this particular case, I'm sorry to say, the concrete truck was short just a little bit, and they had to go get a second load. Well, the second step is to pack the base. After forming the formwork, pack the base, and a plate compactor is used to pack the ground. Then 100 mils of road-based material is added on top and then packed again, and then about 20 mils layer of sand is added to eliminate any possible friction between the concrete and the base. There's a tip here. Large plate compactors can be hired for about $60 a day. This is in Australia. A pedestrian roller, or sometimes they're called walk-behind rollers, are good for clay soil, and plate compactors, or vibrating plates, as they are also known, work best with granular soils. And here's the concrete being poured. The formwork is filled evenly with concrete, spread using rake or shovel to make it flat. The steel mesh must be off the ground, approximately in the centre of the concrete, and sometimes tapping the sides of the formwork with a hammer eliminates those trapped air pockets. And concrete is packed along with the edges with a float. And you can see the concrete being poured through the pipe here. In making concrete strong, the ingredients should usually be mixed in a ratio of 1 to 2 to 3 to 0.5 to achieve maximum strength. That's 1 part cement, 2 parts sand, 3 parts gravel, and 0.5 part of water. And here they are flattening down the concrete after it's been poured. And that is really the next step, to screed the surface. A timber screed is used to level the concrete with a sawing action with a hand float in both directions to bring the concrete cream to the top for a smooth surface. And the tip is to use a steel float for a smooth finish or a timber float for a rough finish. And you can see that they're using a timber float on the right-hand side there. And here he is smoothing it over with a handheld trowel. And the next step is to cut the control joints. Now these joints are placed to control cracking when the path expands in the heat and contracts in the cold. A straight edge is used with a concrete groover to cut these control points in the surface of the concrete at intervals proportional to the path's width. It may actually be exactly equal to the path's width. And at this time, a stiff bristle broom is then dragged over the path while it is setting to make a non-slip surface for walking and to hide any imperfections. The last step is to let it set. It's actually a chemical reaction. This brings together chemistry and physics and mathematics and engineering, calculations. It's just brilliant. Once the concrete is hard enough so that a person's finger doesn't leave an indent when it's pressed into it, the concrete is covered over with a plastic sheet to weigh it down. It's kept damp for 3 days to avoid it drying out too fast, and then it hardens for 2 more days before the formwork is removed and people can walk on it. And you can see in this path that they've made nice swirling pattern to add to the effect that it's a pretty path to walk on. It's patterned and it's also non-slip. So concrete is used in so many building applications, and we must remember the ratios 1, 2, 3, half. 1 part cement, 2 parts sand, 3 parts gravel, and a half part of water. I hope you've enjoyed just exploring both the physics and the chemistry and the engineering properties of concrete. I'm Mr. Mac. Thanks for watching.